So now we're going to look at part B of the same question. It weirdly didn't really link at all, so we're just going to treat it in its own entity. So I'm asked to solve cos of 5y is equal to cos of y, okay? So it looks quite straightforward, but it's actually a lot more in-depth than we think. The best way to do this, in my opinion, is to start to bring these together to make it equal to 0, which is normally an obvious step when we solve things in a lot of cases. Now I'm noticing that I've got a situation that I can apply the factor formula, which is the last lesson that we did on trigonometry. This factor formula technically can come from you doing cos p take away cos q is the same as 2 sine p add q over 2 multiplied by sine p minus q over 2. The other factor formula, the ones that we've got, are for positive cos and for sine, positive and negative as well. You can look back in the lesson and find out there's 4 of them altogether. Okay? So this is the one that we're going to use today because this relates to what the question that I've got. Sorry, it's a negative. So we can write this in this form instead. So what I've got now is minus 2 sine 5y add y, 6y divided by 2, so sine 3y. And over here, p is 5y, q is y, so this becomes 4y divided by 2, so sine of 2y, and that equals to 0. I'm now in a situation, because I've got things multiplied together, that equal to 0, I can start to look at finding some solutions by doing this. So either sine 3y equals 0, or, alternatively, sine 2y equals 0. Okay? Now the problem that we have here is often we can understand obviously if sine of something's 0, it's probably going to be 0, 180, 360 and so on. But we just need to be really careful to make sure we get all the solutions because this has had a transformation, so it sort of squashed it in, so we just need to be really, really careful. The trick to answering this was to understand that if, I'll just use a different colour, if y had to be between 180 and 0, we're looking for solutions in there. There's actually going to be more than you think. So I personally prefer it to be this way. There are many other ways, but what I like to do is say, call it another letter, sine x equals 0, in which case we know that x is 0, 180, 360 and so on. But just so I know how many x's I can include, I look at the conditions that I've got for y. So if y has got to be between 0 and 180, well, 3y must be between 0 and 540. I'm just simply multiplying by 3. So therefore, obviously, if I've said that x is 3y, then that also has to be in the same parameters. So now I know that if I've got sine x equal to 0, I can go all the way up to 540. So I could say that x must be 0, 180, 360, and 540. Okay? So that's all the values of x that I'm allowed. And now when I sort of squish them back in to talk about y, as in essentially reverting the fact that if I've said that x is 3y, well then y must be a third of all of these. So 0, 60, 120, and 180. Okay, so I've sort of imagined that it's an x, worked out the solutions for that, and then brought it back into y afterwards. Okay, that's just personally how I do it, rather than having to translate this graph and transform this graph at all. Okay, so my solutions were those ones there. Okay, now I'm going to apply a similar process for sine of 2y, except now I'm going to use a different letter. I will use m, and so the m is now 2y. So again, if y has to be between 0 and 180, then 2y must be between 360 and 0, and thus m must be in there as well. So if I'm now doing sine m, because m is just 2y, equals to 0. Again, using the same process, I know that it must be 0, 180, or 360. I can't include that higher one, because I can only go up to 360. So that's fine, and then I can quite clearly see that obviously x must be half of those. Sorry, y must be half of those. And then I start to form the solutions that I've got. So essentially, y can be 0, 60, 90 from over here, 120, and 180, bringing both of those different roots to get the solutions together.